we're going to do a quick example to kind of work with our t-tables and get used to basically looking at those and solving problems. So we are looking at phase change materials, and we're given 18 samples. They should nominally be at 2 milligrams, so the population mean should be this, but we're going to actually test that and measure it. So we're given 18 samples, so we know that n is less than 30, so we need to use our t-table. So we need basically this t alpha over 2, because we're looking at basically, as we'll continue reading the problem, basically symbol blah, blah, blah. What is the 95% confidence interval for the population mean? So we need this expression that mu will be equal to x bar plus or minus t alpha over 2 nu, excuse me for that bad handwriting, sx over square root of n, right here. So let's go ahead and solve this problem. So first thing that we're going to need is x bar, s of x, and n. We'll go into our Mathematica notebook. We'll look at, basically these are my phase change materials, samples. So the length, so n is equal to 18. My x bar is just going to be the mean. My s of x is going to be right here. And now I'm going to go back. Let's go ahead and we have x bar, we have this. So we need to figure out what is t alpha 2 nu. So I know that my confidence interval is equal to 95%. Oops, excuse me. One more. Confidence interval equals 95%. I also know that I could express the confidence interval as 1 minus alpha. So I know that my alpha is going to be 5, or again, not as percents. I could just do is equal to 0.05. So my t alpha over 2 is going to be 0.025. And my nu, my degrees of freedom, is n minus 1. So I have 18 samples, so 17. So my t, 0.02517, if I look at it in my 025 and I'm looking at 17, it should be 2.11. So that is going to be, oops, really bad. That is going to be, t alpha is going to be 2.11, and we can see that in my Mathematica notebook right here. So if I shift enter and evaluate this again, that is going to be t alpha over 2 times s of x over square root of n. So my expression will be, or my bounds will be, the population mean will fall between 2.05 milligrams plus or minus 0.328 milligrams. So that's my 95% confidence interval where I expect the true population mean to fall. So very similar to what we've done previously, just using the t-tables. Again, don't be intimidated. They're not very different whatsoever. So you'll be fine moving forward. So thanks, and we will talk more next time, and we'll get into hypothesis testing. Thanks. Bye.